we're going to go over how we can rewrite equations so that they are in slope-intercept form. This is something we would want to do if we needed to know the slope or the y-intercept, or if we need to graph it using the slope and y-intercept. So let's start off with slope-intercept form needs to look like this. Y equals slope times x plus the y-intercept. So we need to have the y value all by itself. So let's look at an example. Let's say we have the problem 3x plus y equals 8. And I need to get the y value all by itself, because our slope-intercept form is y equals y by itself. So that means I've got to get rid of this 3x. So just like we would solve an equation, I need to move this whole thing over to the other side. We do that by doing the opposite, doing inverse operations. This is a positive 3x right now. So then the opposite is to do minus or negative 3x. Once on the left-hand side and once on the right-hand side of that equation. And that is going to make 0, so that cancels out from this side. So we have y equals, and then because these are not like terms, 8 and negative 3x, one has an x and one does not. They are not like terms, so I cannot just subtract 8 minus 3. I just write it as is, 8 minus 3x. We're almost in slope-intercept form. We've got the y by itself, but we're going to flip around the x and the constant. So this becomes y equals, this 8 is positive, the 3x is negative because this minus sign is in front of the 3x, so that's attached. So the negative 3x, and I've got a positive 8. And now it is in slope-intercept form. Okay, let's look at another example. This example is going to be, what if there's a number in front of the y, so there's an extra step. So let's say we've got negative 2x plus 5y equals 10. Okay, so again, similar to how we would solve an equation, we always want to get rid of our addition or subtraction first. So eventually, we are going to need to get rid of this 5. The 5 is multiplying the y, but I want to handle that last. So we're going to start by getting rid of this minus 2x. We got to get rid of this part first. We got to move this over to the other side. So like we did before, we're going to use inverse operations. It's a negative now, so I need a plus or a positive 2x. Once on either side of that equal sign. That's going to be 0, so that cancels out. So I have 5y is equal to, again, these are not like terms. One is a constant and one has an x, so they're not like terms. So I'm going to leave it as is. But instead of what I did up here in this problem, I know I'm going to want that x first, so I'm going to go ahead and write that x first. I have a positive 2x, and then I've got a positive 10. Now I'm going to go ahead and get rid of this 5. This 5 is being multiplied by my y. That's what it means when they're right next to each other. So the opposite is to divide by 5. What I really need to do is I need to take this whole side and divide by 5. Except if I look like this, I can't see my slope and my y-intercept. I need a separate slope and y-intercept in my slope-intercept form. So instead of, or another way is to divide each of these individually by 5. Divide 2x by 5 and divide the 10 by 5. And then this makes 1, so that's cancel, so y is by itself. And then because slope can be a fraction, we can just leave this as 2 over 5. That becomes my slope. And then for this part here, if we can simplify, we should. And in this case, we can. 10 divided by 5 is exactly 2. If you can't simplify, then you can just leave it as that fraction. And then we have a couple other examples. So these here, is 3x plus y equals 8. And this one here, is negative 2x plus 5y equals 10. This is called standard form. When you have the x, then the y, and then the constant on the other side. But let's look at some examples that might be in other forms even. So let's say we have, let's say something more along the lines of this. Let's see, we've got negative 4y is equal to 3 times the quantity 2 minus 3x. Okay, let's say we have this. So there's not really a name for what this is, for what this form is, but it's definitely not in slope-intercept form. So let's rewrite this in slope-intercept form because maybe we want to graph this. So I need to have that y equals mx plus b. So I've got to get that y by itself. It's almost by itself, but before I do that, before I divide by that negative 4, I've got kind of a lot going on this side over here. So I'm going to simplify this a little bit by going ahead and doing that distributive property. So I'm just going to leave that negative 4y alone for right now. Because when I'm trying to find this, I need that b and my mx to be separate. I can't have this parentheses here. So 3 times 2 is 6. And 3 times negative 3x is negative 9x. And then I'm going to go ahead and flip that around so that I have the negative 9x first and the positive 6 second. So we're getting closer to slope-intercept form. Now I'm going to go ahead and take care of this negative 4. The negative 4 is multiplying the y, so the opposite to divide by negative 4. And remember, like before, instead of dividing this whole right side, I'm going to divide them each part individually by negative 4. So y equals negative 9x over negative 4. I can reduce this a little bit because negative divided by negative is going to be a positive. So I can simplify by saying just positive 9 over 4x. And then I can't reduce this a whole lot. I can reduce the y intercept a little bit. I can divide them both by 2. So I can divide both by 2. And that's going to give me a 3 for my numerator. 4 divided by 2 is a 2 for my denominator. And we still have this negative sign here. We don't usually leave the negative signs in the denominator. Most times you're going to see the negative on top, or sometimes you'll see it right out front. It's not wrong if you had left that negative down below. So I could, for example, have this problem. Y equals 9 over 4x plus 3 over negative 2. That's the same thing. We just don't typically leave that negative in the denominator. And then, so no matter what form your problem's in, we're just going to use our solving equations and our simplifying until we get that y by itself and then x in a constant.